Welcome back, guys. This video is about assertion reasoning questions. So these two questions are from chapter 7, alternating currents of NCRT. Okay, let's go to the questions. So first question, a transformer are used only in AC, not in DC. Then the reason, only AC can be stepped up or stepped down by means of a transformer because of induction. So the notable word was induction. So when we think about the principle of transformer, the principle of transformer is mutual induction, right? So mutual induction, so we must have some good idea about mutual induction. Okay, let us see what's mutual induction. So for mutual induction, I need two coils. Let me name it as primary and this one is secondary, and there is no physical connection between them. So when I connect AC to the first primary, because here in the question two things are given, AC and DC. So first of all, I want to know how the things will work when I connect AC here and DC here, right? So when I connect an AC source to the primary, it will produce a magnetic field, and the magnetic field will be a varying magnetic field. So a conductor which is carrying current can able to produce a magnetic field, and the AC will produce a magnetic field, and that magnetic field will be varying in nature. That means its direction will be changing 50 times per second. That's why we calling the AC having a frequency 50 hertz, right? So the conductor secondary is placed in the place where the magnetic field is getting varied and varied and varied. So therefore, due to the process of electromagnetic induction in the secondary, there will be a production of induced current and induced EMF. So that means AC current, if I give an AC supply to the primary, then it can able to produce induced EMF in the secondary without any physical connection with the help of mutual induction process, right? So let us see what will happen in terms of DC. If I connect DC in the primary, it can also able to produce a magnetic field, but that magnetic field will be having a stable magnitude and a stable direction. The direction or magnitude won't change until unless I change this battery connection, or else I vary the voltage, right? So therefore, with the help of AC, I can make the mutual induction process. With the help of DC, I can't able to make the mutual induction, right? So with the explanation, if you think about these two statements, the transformer are used only in AC, not in DC. Yes, because with DC we can't make mutual induction true. That means DC can't work out. That means the assertion is true. So when we think about the reason is only AC can be stepped up or stepped down by means of transformer because of induction. So that's also true. So we can go for the option A. So the option A was both assertion and reason is true, and the reason is correct explanation of assertion. Then we'll go to the second question. The second question is about LCR circuits, right? Okay, at resonance, the LCR circuit has a minimum current. Note the word minimum current, right? Then the reason, at resonance, the LCR circuit, in the LCR circuit, the current and the EMF are not in phase with each other. So both the sentence deals about the resonance condition. Okay, when you think about the resonance condition, the inductive reactance and capacitive reactance must be equal to each other at the resonating frequency, right? So if they are getting equal, and these two sentence deals about the current, right? Okay, let's go for the current equation. I is equal to E naught divided by root of R square plus XL minus XC the whole square, right? So here, when XL is equal to XC at the resonating frequency, this term will get vanish away, or else it will become 0, and that means the inductor effect will get cancelled out by the capacitor's effect. So here, this term will become 0, means the total impedance will get reduced, because the inductor's effect and capacitor's effect going to vanish away. That means the circuit is going to work only under the effect of resistance, and that means the impedance is getting less. So if the impedance is getting less, the current will be high, because the current and the impedance are inversely proportional to each other. When the impedance is getting less, the current will be high. That means the first statement, that is the assertion, is wrong, because here they are given it as minimum current. So then when I think about the second one, at resonance, the LCR circuit, the current and EMF are not in phase with each other. So the notable word was not in phase. So therefore, when we think about the resonating condition, the impedance will get reduced, and XL is equal to XC. When XL is equal to XC, this term will get 0, and the circuit is going to only work under the effect of resistance. That means the only component, or else only passive component in the circuit is the resistance, or else the resistor, right? So that means the current and the EMF in the circuit must be in phase with each other, right? So when we think about the phasor diagram, so the induced current and the induced EMF must be in phase with each other when the circuit is working under the resistor alone, right? So therefore the reason is also wrong, assertion is also wrong. Therefore we go for the fourth option, that is assertion is false, reason is also false. Thank you so much guys. If you like the video, hit the subscribe button.